All right, let's talk about factorization. Now, I know that word can sound a little intimidating, but stick with me. This isn't about some scary abstract math theory. It's really about one thing: learning how to find the hidden building blocks inside a problem. We're going to learn how to take something that looks complicated and break it down into its simple core parts.
Okay, let's just jump right in with the puzzle. Take a look at this expression. At first glance, it just looks like a total mess, right? A jumble of letters and numbers. But what if I told you there's a common ingredient, a hidden piece that all three parts share? Finding that piece, well, that's the whole game.
And that's really what factorization is all about. It's just the process of figuring out what something is made of. The recipe analogy is perfect here. The final expression, that's the cake. The factors, they're the flour, the sugar, the eggs. We're learning how to look at the finished cake and figure out exactly what went into it. Let's bring this down to earth with a simple number we all know, 16. Sure, you can think of it as 2 times 8 or 4 times 4, but if you break it all the way down to its most basic, its prime ingredients, it's just a bunch of 2's multiplied together. That's it. That's factorization. And we're about to apply that same exact idea to algebra. All right, let's open up our factorization toolkit. First up, the most essential tool you're going to have, finding the highest common factor, or HCF. This is all about looking at every single piece of an expression and asking one simple question. What do you all have in common? And you know what? The process is super simple. First, you just find the biggest number and variable that goes into everything. Once you have it, you pull it out and stick it in front of some parentheses. And for the final step, you just divide each of the original terms by that thing you pulled out and put the leftovers inside. Done. So let's put this to the test. We've got 12x squared minus 4xy. Look at the numbers, 12 and 4. The biggest thing that goes into both is 4, right? Now look at the variables. They both have at least one x. So our HCF is 4x. We pull it out front, and then we see what's left. 12x squared divided by 4x is 3x, and minus 4xy divided by 4x is just minus y. It's as simple as that. All right, tool number 2, we're leveling up now. We're moving on to those expressions that have 3 parts, what we call trinomials. Specifically, the ones that look like x squared plus bx plus c. This, my friends, is where the real puzzle solving starts. You know, the best way to learn how to take something apart is to see how it was put together in the first place. When you multiply 2 simple things, like say x plus 2 and x plus 4, you get a trinomial. So our job is to start with that trinomial and work our way backward to find those original 2 pieces. So here's the crucial part. This is where it turns into a fun little number puzzle. For something like x squared plus 6x plus 8, we're on the hunt for 2 magic numbers. And these numbers have to do 2 things at once. They have to multiply to give you that last number, 8, and they have to add up to give you the number in the middle, 6. So what is it? Come on, you got this. Yep, it's 2 and 4.
And I'm going to give you a cheat sheet because who doesn't love a good shortcut? Let the signs be your guide. Rule number 1, if that last number is positive, then your 2 magic numbers will have the exact same sign. But which sign? Just look at the middle term. If it's negative, like in x squared minus 5x plus 6, then both your numbers are negative. Easy.
Okay, part 2 of our cheat sheet. What if that last number is negative? Well, that tells you right away that your 2 magic numbers have different signs. One's got to be positive, one's got to be negative. To figure out which is which, just look to that middle term again. The bigger of your 2 numbers gets that sign. So for x squared plus 5x minus 6, our numbers are a positive 6 and a negative 1.
All right, you've mastered the basics. Ready for the next level? Because things get a little trickier when there's a number out in front of that x squared. For that, we need a more powerful tool. Let's talk about the scissors method. Okay, here's the game plan. We look at the very first term, 3x squared, and the very last term, 12, and we just list their possible factors. For 3x squared, it's easy, 3x and x. But for 12, we've got a few choices, right? 1 and 12, 2 and 6, 3 and 4. Our whole job is just to find the right combination. Now, this part is all about testing things out, so don't get discouraged if the first try doesn't work. It's supposed to be trial and error. So if we try pairing 3x with 1 and x with 12, a quick cross-multiplication gives us a middle term of 37x. Nope, not it. Okay, how about 3x with 2 and x with 6? That gives us 20x. Still not a match. But then we try pairing 3x with 4 and x with 3. We cross-multiply.
The outers, 3x times 3, that's 9x. The inners, 4 times x, that's 4x. And what happens when you add them up? Boom, 13x. That's our middle term. We found it. That's our winner. Okay, so after all that hard work of trial and error, let me show you some beautiful, elegant shortcuts. See, for certain types of expressions, you don't have to guess at all. You just need to recognize the pattern. So the first one is called a perfect square trinomial. And here's what you look for. It's a simple checklist. Question 1, is the first term a perfect square? Question 2, is the last term a perfect square? And the final check, is that middle term exactly 2 times the square roots of those other two? If you can answer yes to all 3, you've found a major shortcut. Let's check it out here. We have 4x squared. Yep, that's just 2x squared. How about the 9? That's 3 squared. Okay, now for the big test. What's 2 times 2x times 3? It's 12x. It fits the pattern perfectly. So it factors instantly into 2x plus 3 squared. No guesswork, no trial and error, just clean and fast. And now for my absolute favorite shortcut. It's so clean, so simple. The difference of 2 squares. And the pattern is literally right there in the name. You need 2 things, a perfect square, a minus sign, and another perfect square. That's the entire checklist. Seriously, anytime you see this, a square minus another square, like x squared minus 25, the answer is always the same. You take the square root of each one, in this case x and 5, and you write them out twice, once with a plus and once with a minus. That's it. It always works. Okay, so we've loaded up our toolkit. We have the HCF, we know how to unpack trinomials, and we've got these awesome shortcuts. But why? Why does any of this actually matter in the big picture? It matters because this is how you take something that looks crazy and complicated and prove that it's actually made of simple, understandable parts. This isn't just a party trick for math class. This is the fundamental skill you need to simplify expressions, to solve equations, and honestly, to tackle pretty much any more advanced math you'll ever see. And here's the best part, the real superpower this skill gives you. You can always check your own work. You never have to wonder if you got it right. Just multiply your factors back together. If you end up with what you started with, you nailed it. You are in complete control. So I'll leave you with this question. We've just spent all this time learning how to deconstruct, how to take things apart, and see the simple pieces inside a complex puzzle. So, what can you build now? What new, bigger, more interesting problems can you construct a solution for?